Today we are going to talk in this session about crosswalk network controller and how to integrate multi-vendor devices. A little bit of introduction. My name is Krishnan Thirakonda. I am a technical marketing engineer in the mass scale infrastructure group in Cisco, and I'm joined by my colleague, Michael Madern, who is also a TME in the same team. We focus on automation solutions for large-scale customers in the what is called as the mass scale infrastructure group in Cisco. So let's get started. What we want to show you today is basically start off with a brief overview of CNC in a few minutes. Talk about what are the customization and extension areas. We have built CNC as a very flexible product. We understand our customers want to do different things, and we don't want to be in the way. We want to make it easy. So we do, want to talk about that. So we do use NSO inside CNC, so that's a core component, and we will be leveraging a lot of the NSO capabilities to support, other vendor devices. And in this case, we will show how to connect a Juniper VMX and manage it. And then we'll go to the demo to show actually provisioning a service and segment routing with Cisco and Juniper through CNC. So that's the plan in the next 20 minutes or so. So the overview of CNC, right? So just briefly, right? So CNC is meant as positioned as a network controller, an SDN controller for IP transport network, right? NSO has been around for a while. It's quite powerful and popular, and I'm hoping that in this audience, a lot of folks have heard about this already, NSO, right? It's been out there for a while. NSO does provisioning quite well, right? But now what we are trying to do is to build a vertically integrated solution to do not only provisioning, but also to present what has been provisioned, the visualization layer, and build in a big, an important component for traffic engineering, the path control element, PCE, and then also bring in service assurance to deploy your VPNs, also be able to verify and test on a periodic basis, on an ongoing basis, and present service health of a deployed service, right? So all of that is important. And some of it is coming as a need from our customers that, now that segment routing technology is available, and it brings in a SDN capability. And how does it bring in SDN capability? Because it actually uses a source routing paradigm, right? So you can actually build paths that are not just routed, shortest path routed, but you can actually go and say, I want for my service to go on a particular path. Either give me nailed up path hop by hop, or give me a criteria that the path should follow, and then pick the best available path and push my traffic to that path, and then do that on a real-time basis, right? So those things become very important to have a path compute element integrated with your provisioning and your visualization, right? So that's the goal with CNC. Inside of CNC, there are basically it's an integrated solution, right? So we do have NSO as the main configuration engine, which you see in green on the right side, talking to the network devices at the bottom. And then we have the path computation engine, which is based on iOS XR 9000, and it's doing PSAP, which is a standard-based protocol for path compute element. So your routers, the head ends, can ask for paths using PSAP protocol. There is a protocol called BGP link state that basically tells us the layer 3 topology with all the T extension attributes that are now distributed in ISIS and OSPF, right? Those can be then also sent to external controllers using link state, BGP link state. So SRPC on the left will consume that and do all kinds of interesting things with it from traffic engineering perspective. And then we have a data collection layer in the middle. To do anything bandwidth aware, you need to collect telemetry of the link utilization at a minimum, right? You need to know how much traffic is flowing to every link, to every policy, every tunnel, and then do fancy things with it that are based on the customer's intent, right? Now, all that the logic of what you want to do is actually in the blue portion. That's where the crosswalk applications are there. And it's a microservices-based infrastructure doing different things, and we'll cover some of it in the next slide. But the main idea is that you have one interface into this whole complex from the north side, right? You either use the REST-conf interface, or you can use a UI. So all of the gray area is in the crosswalk network controller. Looking a little bit deeper, talking about the optional components inside of the blue portion, you will see that these are, we actually ship them as independent artifacts. You can download them from Cisco.com downloads as what we call as crosswalk apps and install them. There is a basic infrastructure, which includes the message bus that's used to communicate between all the components. On the right side bottom, you will see NSO VM with its, also we ship function packs with this product, right? So when you buy CNC, you get what we call a TSDN function pack, which includes the SRT function pack and some example function packs. So which is bringing us to this slide, right? What do you get when you actually order CNC? On the NSO side, you get the core function pack for SRT. It's core because the functionality for segment routing is evolving. It's not too broad, and most customers are doing the same thing. So we made it a core function pack, meaning it's fully Cisco supported as you buy it. The L2 and L3 VPN, as most of us in this audience might know, is very flexible, very broad, and most deployments are very using specific things. So we are shipping an example which can be customized by every customer and in the field for the very specific variants that are being deployed. We also have an example for RSVT, which is a legacy. And then, as you might expect, there is a lot of work needing to be done on SR segment routing TE side of it. There's a lot of interop work that needs to happen between the segment routing PCE and the head ends. And this is also a rapidly innovations are coming in from segment routing. So we do publish a matrix of head ends, XR and XE versions, and then the PCE, which is an XR-based XR9K that we use, that can be used. Again, if you want to do anything beyond those, you would need to validate, right? And then there are a few extra optional packages. In the interest of time, we will not cover any more depth on it, other than I'll mention Service Health is a brand new thing that's actually going to be GA in 4.0, which actually brings in service assurance. So again, I mentioned that CNC is built to be easily extensible, right? There are different areas where you would extend. And as you saw in the picture, that the southbound interfaces are very standards-based, right? We have NSO using different nets. You can talk to different devices. But even the segment routing, the path compute element protocol and BGP-LS are very standards-based, and we use SNMP standard MIBs to get telemetry today. We are going towards GNMI with OpenConfig for future. So those are all extension areas, meaning you can add a different vendor device, you can extend the fastmap code with the templates to create new configurations. We also can support your existing NSO package. We call it Brownfield NSO package, and we have a session later today in about 40 minutes to cover that. So this session is going to talk about adding new device types. In this case, we're going to show an example of Juniper. And one quick thing, and this is something we all know, just to recap, that before you actually head into automation, you want to make sure that you really understand the routing platforms, the technologies, and finally, you want the configurations that you're going to deploy, right? You want to validate that. And when you deploy CNC, you also want to validate that some of the interfaces that are needed to work with other vendor devices also are validated in your lab, because in the Cisco lab, we are validating against Cisco platforms. Now, Cisco Professional Services, our CX teams, can, of course, help with this. For the next portion, I'll hand off to my colleague, Michael, to cover the NSO implementation and demo. Michael?
Okay. Yeah, so I'm going to cover the work we've done to add a new vendor support into CNC, Juniper, as Krishnan said. Now, if this is the first time you're seeing CNC, it may seem a little advanced, but if you're already familiar with NSO, you'll see it's quite straightforward, and it should sort of reinforce how CNC is using NSO internally. So, as we already said, the first thing, the key thing, is you need to know the network configuration. So in this case, we had to figure out, the Junos equivalent for what CNC is applying to the Cisco devices. But once you have that, then it's fairly straightforward. As you would when you're creating any package in NSO, you need to make sure you have the NED, and that the NED supports the configuration you want to generate. And then you can create a package and you implement the logic. In this case, you need to use Python, and you can use templates optionally. So this middle box, I'm going to go into a lot more detail in the next couple of slides. And then on the CNC side, it should just work. Like, the visualization should just work. The only thing is the device needs to support some of these standard MIPS. As long as it does, it should work. But we need to go and test and verify. Now in CNC, it supports several different services, as we saw earlier. So the ones that we've added Juniper support to are SRTE and L3 VPN. And for SRTE, you can have a static policy or a ODM policy on demand, which you can then use in your VPN. So because we don't have very long, the way I'm going to structure this is I'll focus on the SRTE. I'll show how you can extend that package, and then I'll show in NSO provisioning an SRTE through the NSO CLI. But that NSO environment is part of the, a bigger Crosswork environment. So I'll then hand back to Krishnan, and he'll be able to show in the Crosswork UI how that looks, and then he'll then go and provision a L3 VPN. So just so we're not repeating the same thing, so you'll see both kinds of services in both UIs. So just before I switch to NSO, just to give you some context, this is a screenshot of the Crosswork UI. So you can see the topology we have here, and these devices are in NSO. That's where they're from. So you see we've got nodes 1 to 8, and these are Cisco devices. And then VMX99 is the Juniper device. And that's where I'm going to provision SRTE policy. So VMX99 will be the head end, and we'll set node 4 as the tail end down here. So before I do that, we'll just cover a little bit of how you actually add the extra support, how we did it for Juniper. So the Crosswork comes with the TSDN packages, so they're the packages that go inside NSO, and they already have service models for SRTE. So this is just a high-level view of that SRTE model. And what we need to do is we need to add the logic to map to a Juniper device. And the way it works is when you configure a policy, the core SRTE package will look up, using this dynamic device mapping, it will look up the NED ID of where you're configuring the policy, and it will look for the class that's going to have the logic on how to implement it. So to add the Juniper support, we had to create an entry, to say that when you're using the Juniper NED, call this class. And then we had to implement that class. And to implement it, you just need to support some standard functions. So if you're creating a static SR policy, as we are in this case, you need to implement a function called conf SR policy. And this is just a Python package. You can implement it any way you like, but to keep it simple, we just created a template. So the Python package applies a NSO template that has all the logic in there. And then one other thing you can do with a static policy, you can, in your path, you can have an explicit SID list. So if you're creating a SID list, then we need to have this function implemented, conf segment list. And again, that's just done with a template in this case. And just to be clear on the left here, what happens is that the policy actually references the SID list. So when you create the policy, it will also create the SID list and call both these functions. And then the other kind of policy you can have is an ODM policy, and that works in a similar way. If you create the ODM policy, the head end, which is the device that's going to get the configuration, the NED ID for that will be used to look up which class, and you need to implement a function called conf SR template. And that covers it really. I know this slide is perhaps a little complicated, but this hopefully demonstrates exactly how it works inside TSDN. And at the end of the session, if you're interested, there's a references slide, and we have a link to a GitHub repository that has these packages. So if you go on there, you'll see the package is really that simple. It's just a very simple Junos Python class, and then these 3 templates. So I'll just drill down into one of these in a bit more detail. So we'll just look at the static LSP. So we have the service model on the left. So this is what's provided by the core SRTE package. And then on the right, the mapping to the Juniper template. If you're not that familiar with segment routing, this probably isn't that interesting, but if you do know, how it works on Cisco, then this is the equivalent for Juniper. So everything needs to go under source routing path, and then these mappings are all fairly straightforward, really. The interesting one here is the PCE. So if you want to delegate to the PCE, we need to make sure this LSP external controller is set to PCCD. And then with your path, if you're creating a dynamic path or you're wanting to do any constraints, then on Juniper, you need to create a compute profile. So part of the template has that as well. It'll create a compute profile and then, again, just map the relevant parameters from the service model. So for things like the metric type, and if you want to do some affinity, that's implemented as admin groups on Juniper. Now, I've just taken a snapshot of the template here and simplified it a bit for the slides, but I will now just quickly switch over and show the actual package. So if you were to download, clone the Git repository, you would see there are two packages in there. So inside the SRTE package, which is one we just looked at, I'll just call out a couple of things. We've got the dynamic mappings. This is what we just saw. So you could load merge this or just create this entry in the CDB. And then the Python class. So I just said it really is pretty simple. It's those three methods that we just looked at, which are here, right? The conf segment list, conf policy, conf template, and these just simply call a static method up here. So for example, for the static LSP, calls this method here, which just creates an NSO template, sets the head end and applies a template. And if we take a look at that template, it's what we just saw in the slide. If you can't see this, don't worry, it's available in Git to have a look. But you can see here it creates the compute profile if we've got any constraints or if it's a dynamic path. And again, the things we just looked at. So it's just got the actual processing instructions that I omitted from the slide. But you can see, for the metric type, it'll map, say, the metric type leaf, which is actually the enumeration. It'll map it to separate nodes. That's how it is on the device. And same the affinity rules map to admin group on the device. And I don't want to go into too much detail, but on Cisco, you can have multiple candidate paths, and each path can have multiple SID lists. And on Juniper, it's a little different. You have primary and secondary paths. So this template just tries to map the the various combinations to from how you could do it on Cisco to how it could be done on Juniper. But I would say this is just we've tested this and it works, but it's just an example. So if you do take this and try it, then you may need to tweak it for your use. So I'm going to just quickly show actually creating one of those. So I'm in the NSO environment here right now. I'll go into config mode. So it's the service model we just looked at. So it's SRT policy, and I'm going to create this policy. We use a standard naming convention. So I'm going to call it SRTE. We'll put the color in the name and the endpoint, which is node 4, which is .4. I need to fill those parameters in. So the tail end 19.1.4, color 777, and I'm going to set the head end to the Juniper device, BMX99. And let's then create the path. So we'll create a dynamic path. So I've got the options there, dynamic, and let's set the metric type to PE. And I'll also set the delegate PCE option. If I do a commit try run, it's just going to apply that template. But the thing is, you can see down here, right, we've created this using the core function pack SRT model, and then through what we just saw in the slides, it's then invoked the template from that extra package, and here it's generating the configuration from what I've just entered, and you can see it's creating the compute profile and etc. So I'm going to go ahead and commit that, and then in a minute you'll be able to see that in the Crosswork UI. And just to show, if you're not familiar with NSO, it's how easy you can make changes. So I can just go in here maybe and change the metric type to IGP, and maybe also add a constraint, for example. So let's do affinity. Let's do exclude color. Say exclude color blue. If I do a commit try run, all that's going to happen is NSO is going to reapply that template and see the differences. We'll see, ultimately it's going to add an admin group here and switch the metric type. But I won't apply that. I'll leave it as it was before. Just finally, before I hand back to Krishnan, on the L3 VPN service, it's a very similar scenario. You just map the L3 VPN model, when you create an endpoint, it's the access PE. It looks at the NED ID from there. You need to provide a different class for that, and you need to implement a function called conf L3 VPN. And we can very quickly just see how that looks on here. I'll just go straight into the template. So the L3 VPN template, this one's a bit more complicated, but if you're familiar with, for example, the example L3 VPN package you get with NSO, it's very similar. There's just a couple of extra things for segment routing. So we need to create a dynamic tunnel here to map the color to the ODN template. And there's some extra policy statements for actually adding the color to the BGP exports. And one other thing is in the model, it's using the Cisco interface name. So this template will translate to the Juniper ones and then create the interface, create the VRF, and a few L2 things from the model at the bottom. But I think with that, I'll hand back to Christian, and he can show how this looks in CNC.
Thank you, Michael. So let's switch back to CNC. So let me go and share the desktop. And let me also share the PowerPoint. I wish I knew how to do it in one step, but anyway. This is the CNC UI, and this is the same snapshot that Michael shared. So we basically offer three ways of looking at your network. The topology is basically your layer 3 topology, inventory, with all the devices, router versions, and platforms. As you can see, there's Juniper in the bottom here. We offer a traffic engineering view where you can see all the traffic engineering policies that are created. And this is the one that just was created on Michael created, right? So this is basically showing you, and we have a live topology view where we not only show the links and the coloring is based on the link occupancy, but we can actually overlay the paths, right? The SRTE policy paths that were created. As you can see, this is the one that we are using. And you can actually, in some cases, you may choose to use loose hops. Then we will actually calculate the intermediate hops and show it to you. That's what the show IGP path does. You can actually go into more details to see what is the traffic engineering path compute, data for this, right? So this is where we do API integration with the SRPCE, which is what calculated the path and gave it to the head end. And here's the candidate path request that came in. And here are the hop by hop calculation. If you know segment routing well, this is what you want to see, because in this case we ask for a T metric optimization, meaning don't use IGP metric but minimize the TE metric. In that case, it ends up using what is called as adjacency segment identifiers, right? Adjacency SIDs, and you see there are 3 hops that were used. So you can see get a lot of this detail here, and you can get all of this through API as well. And you can have a lot of knobs to change, add more constraints. You can do disjointness, affinity, things of that nature that are all part of the segment routing TE functionality. Now let's switch into the VPN services view. So we also, in this demo, we implemented the VPN package for Juniper as well. And the way, what we'll do now is to go ahead and provision a VPN. So let's go to the provisioning. As you see, we even label it provisioning NSO, meaning provisioning screen is actually painted with the YANG model that the NSO northbound interface has. And then you can actually click here, and the UI is basically a form interface to fill in the northbound model. Handily, we also have a way of loading the same payload, JSON payload, into the UI, so we can do it a little bit quicker. So I'm going to import the VPN payload, and it loads the pages, the form. For the northbound interface in CNC, we implemented the layer 3 network model that IETF is now it's a standard. But when we shipped this product, it was still draft, and we used the draft and we implemented that. So we intend to keep aligning to that draft, and so that's why you see the VPN node, IE profiles. These are all coming from the L3 network model YANG draft. It's a YANG model for L3 VPN network model. So we have 4 sites, 4 PEs where this VPN will have VRF. The route target import exports are coming from this construct called IE profile, IETF, CNM profile, I think is what it stands for. Here you see route distinguisher and VPN targets, what VPN targets are going to be imported, exported. And then, you see there's a value we are importing, exporting, and also we're binding it to a particular route policy. And I'll mention the importance of that in a minute. So we also have exposed the API call into dry run, so NSO can do the dry run calculation and show on the UI. The idea is that the operator of the network does not need to switch between different products in the complex, and we are trying to present CNC as the main interface for the network. But the output, as you can see, is coming from CNC. I'm going to skip down all the way to the VMX template, so you can correlate this to the template that Michael just showed. So here's the device, VMX99. Here's the PEC interface. Here's the dynamic tunnel that we are configuring. We are binding it to 2 source path templates for different colors. That's where the ODN template will trigger creation of underlay SR policies. This is the on-demand next stop. And then the routing instance where we are creating the VRF itself is here. We are doing VRF export. If you're familiar with Juniper configs, this is how they configure it. So let's close it and then commit it. So again, now we are asking through API for NSO to push the configs to devices. And once the device is configured, it'll basically, behind the scenes, the routers will call using PSA protocol to the SRPC in the CNC complex that is already configured. That's like base config. Get the path, bring up the SR policy, and then, that'll be also reported to SRPCE. When you go to this screen, VPN services, you will be able to see all the deployed VPNs. So in this case, we deployed VPN 101, and you see it's a 4-site VPN. It was blank earlier, if you noticed, and now we have deployed it. This part of the screen is painted using the northbound interface of NSO. So we know that NSO has a type of VPN, L3 VPN, with this service key. It has 4 sites. So we go to the topology and color these PEs. These are participating. The more interesting thing is to go into details and look at, the configuration. This is important because you can now get the actual payload and then modify and use APIs or use the same payload in the JSON in the UI to load it. So it makes creating new services very easy, or to integrate with a northbound workflow engine or some kind of business system very easy. Now, if you go to transport, this is the part where we are integrating with the underlying segment routing, right? So you can see that between the full mesh of PEs, we actually created dynamically a set of SRT policies, and this was triggered by the L3 VPN route policy, which basically says for these prefixes coming from these CEs, we attach a SRT color, and then the head ends, each of the PEs, a head end as well, will bring up a dynamic tunnel. In this case, there's a Juniper to Cisco, the 3 PEs. We can take a look at one of them just to see. So you can see that the hop by hop path calculation was done. You can see it on the UI. You can see if it was loose hops, it will also resolve the intermediate hops. You can go into view details to see all the paths that were calculated. As you can see, this is the BGP path. In Juniper, the dynamically created path has this format: the tail end, the color and hexadecimal, and then the dynamic tunnel name, followed by the SR template, which is ODN_C_4001, which is what Michael implemented in the NSO template. So this is really what we wanted to show you, that it's really easy to integrate with CNC, and it follows the same principles as what NSO has in terms of multi-vendor implementation patterns, your template plus flash map code. CNC itself is very standards-based, so the configuration interface through NSO and NEDs is very powerful, as you already know, but we also use PSAP, BGPLS, which are standards-based on SNMP to get the additional information. And of course, anytime you venture into multi-vendor production networks, a lot of interop testing should be done, and that should include verifying CNC's interfaces work with the new platform. And then finally, a bunch of references in terms of where you can get the sample code that Michael showed, and some more details about the CNC and its APIs. With that, I think we are at the end of our allotted time, and we'll pause and hand it back to the team.
I have a question for you, Krishnan. So how did the L3 VPN provisioning bring up the SRTC policies?
Right. So this is using a technology called on-demand nexthawk. So when you provision L3 VPN, you have an option. I mean, if you want segment routing underlay, full mesh, or any kind of underlay with segment routing paths, you can actually indicate using BGP color community. So there's a route policy that was added. The route policy basically colors all the VPN v4 prefixes, and the head ends, basically the remote PEs, when they get this VPN v4 prefixes, they look at the color and they automatically instantiate the SR policies. Mm-hmm. There is something called an ODN template that is actually pre-positioned. And in Juniper, that's called, I can actually show a little bit of Juniper. It's called source path template, basically. So if you go into this config, there is the source path, source routing path, and there are templates. So you see this template. What this template is doing is that till a colored prefix is received, it doesn't do anything. But once you get a prefix with a color, it'll then bring up a tunnel with this criteria expressed here. So this is similarly done in Cisco and Juniper. So that's the on-demand nexthawk template. Hope that answers the question.
Yeah, thank you. So Michael, is there any limit for how many different device types that you can support?
No, there's not. So CNC doesn't impose any limit. It's just the usual NSO. So long as you've got the NED, you can do this as many times as you want. As long as you have the NED and it supports the configuration, you can create support for as many vendors as there are NEDs for.
Yep, got it. Do we have any questions from the audience? No, I think with that, we thank you for a very good presentation. Thank you, Michael and Krishnan.
Thank you.
Thank you.
Thank you.